the presentation about our paper Swiss Judgment Prediction, a multilingual legal judgment prediction benchmark. Let me start with an example of the task. So we have the facts of a court decision as input, and the model should then predict the judgment outcome, which can be either approval or dismissal. So we have a binary classification task. There are many jurisdictions which are very overloaded. For example, you can see here in India there are almost 24 million court cases pending for only 17,000 judges. And in Brazil and US immigration we have a similar situation. This means that cases can take years, if not decades, to be heard. So with the legal judgment prediction task, we want to assist judges and clerks by speeding up judicial processes and improving their quality. Additionally, it can assist lawyers by identifying weaknesses and strengths in their arguments. So I'm talking about the dataset construction here now. So we have 3 languages occurring in Switzerland: German, French, and Italian. And we started out with over 150,000 federal Supreme Court decisions. Then we slightly decreased the size by constraining the date, and then the next column, rulings, says for how many decisions we actually found a rulings section, and the judgment section says for how many of these decisions we could extract a judgment. But this includes also other judgments like write-off or inadmissible, which are only which can only be inferred with external data. So we assume it cannot be directly inferred by only the facts. That's why we binarize the decisions to only approval and dismissal, which should be clearer from the facts. We end up with a little bit over 85,000 decisions. So as you can see here, the label distribution is quite imbalanced, with a bit over 20% approved cases and the rest dismissed. Then we also have metadata for the legal area distribution. So we can see here that there are 5 big areas in the Federal Supreme Court of Switzerland, with public and penal law being the biggest areas, and less cases in civil and insurance law. Switzerland is made up of 26 cantons, which are listed here. Most of them are German speaking, which you can see in the left column. If there is a dash, it means that this language is not spoken in that specific canton. The bold numbers mean that there are over 20% of the decisions in that canton regarding the language. And the low resource cantons are listed with underline. So that means it's less than 5% of the cases per language. There is also the Swiss Confederation, so that means it's that the decision is coming from a federal court already, but not the Supreme Court. Then for some decisions we also were not able to recognize the previous court. As you can see here, the documents are quite long, so most of them are more than 512 tokens long, and with the average being around 800 tokens. So we investigated several state-of-the-art models on this binary text classification task and compare them to baselines. We mainly want to focus on the macro F1 score because, as you can see, already a majority baseline outperforms most methods in microF1. The standard models, which can process up to 512 tokens, are a bit worse, as you can see in the second row. And then we experimented with two different types of long models, which can both process up to 2048 tokens. As you can see in the right column, the Italian performance is a bit worse in comparison to the French and German data, which is probably due to the to less cases being available there. We also investigated the performance based on the legal area, and there we noticed the strikingly good performance in penal law, which after consulting our lawyers, we conjecture that this is the case because of more stricter rules in penal law, and also because of in dubio pro reo if there is not enough evidence. The worst performance we observe in public law, but there we didn't do any error analysis so far. Then comparing by the origin canton, we see quite different performance of the models based on the origin cantons, so that also questions the robustness of the models. In this graph, you can see the macro score of the different variations of the BERT models, and it's clearly evident that the standard model underperforms the long and hierarchical version on the part from 513 to 2048 tokens. Because the long models can only process up to 2048, we see similar performance in the even longer documents. There is no, or we cannot see any difference in the performance based on the publication year on the test set, which is a good thing. So to conclude, we release a diachronic multilingual judgment prediction benchmark, which is available on Hugging Face, and the highest macro F1 score is around 70, so there is plenty of room for improvement. We also release interesting metadata like the date of the court decisions, legal areas, and cantons of origin. In future work, we would like to investigate cross-lingual transfer techniques, for example adapters, to possibly improve poor performance in the Italian subset. Another possibility would be to transfer from entire dataset or even from other legal judgment prediction datasets. Also, we could use legally oriented models, so BERT models pre-trained on legal data, but this only exists on English data so far. Another possibility would be to investigate more long input models to improve performance on these long documents. Thank you very much, and I'm looking forward to your questions.